So welcome back, everybody. We are continuing on our geometry break, and we're just going to do some algebra today, just to make sure we don't lose it. So we started yesterday with GCF, where we did a few of the greatest common factor things. Now, we didn't do a ton of it. We're always going to check for GCF. Like, that's our starting point. Now, as we go through, we looked yesterday at the end, we started looking at trinomials, and specifically, we are looking at this idea called grouping. Now, as we go through, the goal today and what I'm hopeful is, one, it's good review. And if you were not great at it last year, that's okay. We don't do a ton of factoring in here, but I know that I'll have all of you next year again in a different class, and factoring is going to be a part of that. So we don't want to lose these skills. When we factor by grouping, we begin by taking this leading coefficient, which was a 1 in this case, and multiplying it by this term back here to get a 5. And then I left off with the question, what multiplies to be 5 but adds up to 6? Now, sometimes this part of the problem is really easy. Sometimes it's hard. This one winds up pretty easy. As long as we do things in a systematic fashion, we won't miss them. And with a small number like this, some of you probably already have it, I would always start as follows. I'm going to list all the possible ways to get to 5, and hopefully we find the one that adds up to 6. What's the first number in your mind that goes into 5? 1. 1 times what? Now check it out. If I multiply these, is it 5? If I multiply them, does it add up to 6? If I add them up, does it add up to 6? 1 plus 5 is 6. These are the numbers that we're after. Now, if you didn't see that, is there another way you could get to 6? 1 times 5, to 5. 1 times 5, there's no other way, right? Okay, so with this, here's the big part. This is going to be this trinomial or trinomial right here, and we're going to rewrite it as a four-nomial, and we're going to group it. Andrew, you should be working along because you're going to be doing a few of these on your own, okay? All right, when I say we're going to rewrite it and group it, that doesn't mean a ton here, but let's actually rewrite it, and I'm going to use these numbers. Now, I'm going to color code specifically. I have 1x squared plus, and all we're going to do is just write this in a different way. Instead of writing plus 6x, which is true, could I write plus 1x plus 5x? Does that still say right now x squared plus 6x if I simplified it? Okay, so it's the exact same thing. Plus 5 on the end still. When we find these numbers, I refer to these as my magic numbers. We are simply taking this expression that we started with and rewriting it in an equivalent form. It means everything the same, it just looks different. Okay. This is still plus 6x. We've just written it differently. Now, the benefit to writing it differently is that we now have 4 terms. And the reason we want 4 terms is because I can group or associate stuff however I see fit, as long as I don't magically change something from addition to multiplication or vice versa. So here's what we're going to do. We found our numbers, and they worked. We are going to now introduce groups. And I want you to add these groups here. With really careful attention, we need this sign to be in between them. If we group it and put the parentheses in front of this, it all of a sudden changes to multiplication stuff. Okay, we now have 2 groups on the board. And just to be clear, here's a group and here's a group. Any questions yet? Ashley?
So we did x squared plus 6x plus 5, right? What if I did 1 times x squared plus 6x plus 5 inside?
So you can, because you did GCF, right? But the GCF, if it's just 1, it doesn't change anything. I wouldn't ever write that because we always will. And then the other part that I want to touch on, I heard you say 6x plus 5. Do you have 6x plus 5x written down here? Or do you have 1x plus 5x written down here?
No, like 1 outside, parentheses, x squared plus 6x plus 5.
So you can do that, but what I just want to highlight here is if we write this, does it really change anything?
No.
Nope. So even if we do this, we still need to do these multiplies, the 1 and the 5, and we still have the same stuff going on. I wouldn't ever take out a 1 if that's all that's going to take out, especially at the beginning of a problem. Okay. As we're here, we're almost done. what could I possibly take out of both of these? And I'm going to make this note. We're going to say factor GCF from first group. Now, this one's always weird because typically we want the GCF of both, but it won't always be the case. Is there something that goes in to both of these? Camille whispers confidently X, I think. If I factored an X out, or if I divided by X, because it's the same thing, what would it leave behind? Ray claims X plus 1. Do you guys all agree? If you wanted to check, it's easy enough to check. If we distributed, we'd get X squared plus 1X, which is exactly what I have written. I'm convinced is okay. Now, here's the deal. We've done the GCF from the first group. Once we have this, the wording is ugly, but we're going to try it. What could I factor out of this one to ensure that I leave behind the exact same thing, X plus 1? Or what's the GCF of this? My second group. What goes into both of those? A 5. Now, if I factor out, notice my plus sign is still here. If I factored out a 5, what would it leave behind? X plus 1 again, right? Okay. For this, you guys are going to help me come up with the words for this because it's ugly to talk and write out. It's easy to talk. I need these to match. Whatever I take out of this from the first group, it's going to leave something inside. This second group, whatever I factor it out, I just need it to make sure it matches these two. If they match, we are correct. And I'm convinced that we're right. I'm going to say factor GCF from first group and something, and it was a GCF in this case, but it won't always be, from the second group to match inside. Now, this is awkward wording, but I've never seen it expressed in a way that wasn't kind of awkward. This is what I'm talking about matching. They're both X plus 1. Okay. As soon as we have it, and it's really convenient that it works this way, we know we're correct if we get these to match. The last weirdest part of this, we're going to take a little side trip, and you guys don't have to write it down, but I want to make sure we can see a connection because it felt like magic when I learned it, and I never truly understood it until somebody explained it a little differently. We have this thing completely factored now, but we're going to do a little work over here. You do not have to write this. I just want you to think through it with me. Let's say hypothetically that I had something like X plus 5 times X plus 1. And instead of factoring, because this is already written as factored, and I said, let's distribute this, or FOIL. Do you guys recall how to FOIL? Okay, so I had one person say yes. Distributing, whether we call it FOIL or not. When you guys do this multiplication, do you draw these lines? Okay, I would encourage you to, if you ever get goofed up with these, but this is the first part of FOIL, right? First times first, and then outside times outside. As I do this, I want to notice what happened. I just took X and I multiplied it by X plus 1. Is that the exact same thing that I see written here? Now, it's weird because it looks different, but it's the same operation, right? Plus, when my second part of FOIL, I'm going to take this 5 and I'm going to distribute it to what? X and plus 1, which I think comes out to being 5. And if I wanted to write it, I could write it like this. Do you guys agree? Now, all that we're doing this way is called distributing. Going this direction is called factoring. If I get to this situation where they match, which is exactly what happened here and here, then we can factor this thing completely down. I see two factors. One of them is this piece, and I always underline it. One of my factors just now was X plus 1. Based on this, I know that the other factor is going to have to be X plus 5. And notice that it shows up X and plus 5, X here and plus 5 here. There's our other factor. We have now completely factored this thing out. We could confirm back to this that this is actually what we've done. We could FOIL it back out. I assure you, we come up with this. Lots of blank faces in here. Looks familiar. Definitely to Lily, 100%. Others. Raylene, what do you think? Okay, Carson? Like, maybe not remember how to do it, but you remember seeing problems and doing problems like this. Okay, let's do another one. I'm going to try to work this one. I'm not going to annotate near as much, but let's do a few of these. If you can hold off for 1 second, one more would be good, but if you're going to pop, absolutely. Okay, let's do one more. Let me grab my fancy calculator so we can get some more interesting ones. Okay, I lied. I don't have my fancy one right there. Okay, let's knock it out. We have x squared minus 12x plus 11. And we're going to get uglier numbers or bigger numbers here in a minute. I want your guys' help going through this. Now, we're going to replicate the process. Do we want to do one more class-wide before I call in individual people? Follow-up, it's going to seem like an unrelated question. Does anybody in here have food allergies? You're allergic to peanuts or to almonds or to chocolate or to coconut? Okay, so here's the deal. You can volunteer your answers, and I'll make sure we get a different person every time. But if you willingly suggest what we do, I will throw a piece of candy directly at you. Ray, what would you like to do first?
We should find what multiplies to 11 and adds 12, which would end up being 1 and 11, I believe.
So, I like what you're saying. We multiply those to get 11. If we do -1 times -11, do they add up to -12? Cool. What do you want? Do you have preference? It is? Okay. So, check it out. We found our magic numbers right off the bat. 11 happened to be prime. If we did positive and positive, why doesn't it work? Yeah, it would add up to a positive 12. We need that to add up to a negative. This is the only way to make it happen. Okay. As soon as we do this, I'm going to rewrite this trinomial as a four-nomial. I'm going to leave some blanks in here, and they're like large blanks in here. How would you like me to write -11? Lily? Ooh, I disagree with you. I still I like that more, but I still disagree with you. Ashley, what is she missing? Good. We need the x in there. Now, Lily, your answer is close enough. We could just do -11x here. I would always encourage add that plus sign in between. Lily, what do you want? Ashley, what do you want? M&M's, peanut M&M's, Butterfinger, Hershey's, Snickers, Milky Way. There's also Almond Joys, but that's my favorite. If you want an Almond Joy, I can give you an Almond Joy. You want an Almond Joy? No. Okay.
I think you're the first person I've ever heard say that.
Okay, you're wrong. Mounds bars are better. We can all agree. But, all right, we have to have this. Okay, so love that. We have this rewritten as a four-nomial. I'm going to use this red color only in this step. What am I going to add to this problem? Somebody who hasn't answered yet. What did we add here? So we found our numbers, and then we wrote it. Shout it out. First one to say it, I'll throw you some candy. Other than Ray and Lily and Ashley. On this one, I put those numbers right. I just put +1x and +5x. And then what did I do with them? Combined. Can you use a different word? There's something. Were these here the whole time?
Oh.
So what should you think I should add? I'm going to add parentheses. Vincent, what do you want? You want the list of candies again? Almond Joy, peanut M&M, regular M&M, Milky Way, Snickers. There's some Reese's in here. There's a Kit Kat. There's a Hershey's. Almond Joy? All right, good choice. You're not allergic to almonds, right? All right, so I'm going to add parentheses. Here we go. Now, I'm going to make a mistake, and I want you to tell me what my mistake is.
plus.
Yep. Now, do you guys understand why this destroys it? If I tried to rewrite this, I would have to FOIL, and I would get negative 11x cubed right off the bat, which is nowhere in my problem. We have to move this here. Perfect. Okay. In this group, what's the first thing that comes out?
So
Oh, go ahead.
Nothing between in that big gap right there.
It's just the size that I wrote it is large. Yep. There's nothing in here other than negative 11x plus 11. Okay. Where would you go now?
You would take out something.
Be more specific.
Take out the x.
Good. I'm going to factor an x out. X minus 1. What would you like me to hook you up with? I'm certain there's one in here. There's like a million candy bars in here. It's on the bottom, yeah. Boom. All right. Just so you know, I'm not going to do this all hour. This is just everybody's going to get one right now. Okay. Now, I'm cool with this. We factored out the x. On this one, it is the GCF. And regardless, in my mind, what I think is, what do I need to factor out to leave behind a single positive x? Because that's what I have right here. What could go into both of these and leaves a positive x? If I factor out a negative 11, and notice I don't write plus negative 11, I'm just going to write the minus 11, and that would leave behind an x and a what? Minus 1. Awesome. What do you want, Camille? Give me a break. Sorry, terrible throw. My bad. I'm going to start throwing left-handed too. So, all right. Are we done? Almost. Like we are, the end is in sight. Am I confident that we're correct at this point? How can I tell? These match, and they have to match. And if they do match, I'm golden. Can you tell me one of my factors? So just to be clear, these are factors. Carson, give me one of the factors. I know you already answered the question, but.
Factors?
Mm-hmm. So I'm going to use this one. We're at this part, right? These are my factors. Here's a factor, and here's a factor. X minus 1 is a factor. Wonderful. Andrew, can you give me the other factor? What are the other parts out front that we haven't written yet?
X minus 11.
Boom, and we have it. Raylene, I skipped over you. I don't know what you answered a question. What kind of candy do you want? Give me a break. Nice catch. Andrew.
Just do the Snickers.
Need a minute? Cool.
It's the same the commercial.
Oh.
I have been?
Yeah.
Give me a break. Yeah, fair. All right, boom. We have two factors of this. Okay, I want you guys to do one on your own. Sweet. It's going to be the same difficulty, and we're going to see if maybe, just maybe, there's something in common between these three. So, now you can, yeah. All right, one more. Carson, what's your favorite number? 16. So here we go. C, I want to do x squared plus 16x, and I got to think out an ugly one here. Plus 64. Now, for this one, we're going to start it together because I do want to show the systematic way because our number just got bigger. I always begin, and realistically, we should be checking for greatest common factor every time. I just haven't been including one, which is fine. How do I start these problems? What's the very first thing that we do? You divide 64 by 16. Why?
Did you make this one a weird one, and then you made it like the cleanest one yet?
I would say there's parts of it. Ashley, I don't quite understand, but it doesn't mean that you're doing something wrong. Did you learn to factor with Mr. Russell? No, you're good. Like some people, there's a group of kids in the school who do something wildly different than what I've ever done. and sometimes they do it right, but it's just some crazy trick that I think is Japanese math, and I don't know where they learned it. If you happen to learn some Japanese math, you might be doing it that way. Okay, every time that I do it, it's going to start like this. I draw these lines, and what do these represent? Like, why would I draw them? Oh, too many answers at once. Why do we draw the lines on the other ones? What do we do with those every time when we start it? Can we just multiply these? I think so. What's 1 times 64? Do you guys all have this written on your page? Why you guys just leave me blank then? Like, Lily, I appreciate you just trying not to answer over and over, which I'm cool with. Okay, I now need two factors of 50 or 64 rather that do what? Okay, now some of you might be really good at the mental math part of this. And if that's you, awesome. If it's not, awesome. I want to show you what I would encourage you to do every time if you have any trouble at all finding these numbers. If we just jump like randomly, if I start and saying, oh, well, this is 16 times 4, like that's a weird place to start. Now, I do this, and whether I write it or not every time, but if I struggle with it, and if you struggle with it, we should write it. Does 1 times 64 multiply to be 64? It doesn't add up to 16 though, right? Like there's an issue. I'm going to start and I'm going to go through this systematically. And all I mean by that, I keep saying this over and over, but every time I do this. 2 times what? 32. Does 3 go into 64? It doesn't. Does 4 go into 64? 4 times 16. That adds up to 20. We're getting closer, right? Because we had 65, 34, and now these add up to 20. We're getting closer to this number. Does 5 go into 64? Does 6, 7, 8. 8 times what? And what do these happen to add up to? Notice they're there. The first two problems, and Ray, I agree that this is a nice problem, but the first two, we just had a prime number and it was just immediately clear. Once I found these numbers, what do? So you say group it. What do you mean group it?
Well, I've been doing the shortcut.
Okay, so you're
doing that too.
okay. I can rewrite my 3-nomial as a 4-nomial, right? What am I going to replace 16x with? 8x and 8x. So let's do that. X squared plus 8x and plus 64. And this time I won't have as big of an awkward gap. 8x plus 8x. Now, again, I just want to stress, these look different and they're written different, but really and truly, these are the same. These are equivalent is a mathy word for that. These guys match. They just look different. Now, by finding these numbers, I'm going to add my groupings, and we're going to see something super convenient happen. Vincent, what is something that goes into both x squared and 8x? So we can't take out the 8 because it's here, but they do both have an x, right? If I take an x out, what stays behind? So not the square. This is x times x, right? If I removed one of them, do you agree it's just an x? Okay, plus 8. Good. Carson, is there any common factor between these two? Good. If I do that, what does it leave behind?
X and 8.
Do they match here? Cool. There's one of my factors, x plus 8. Now the other factor, this time it's weird, and Lily will have the language to say why it's weird, I think. We'll check here in a second. What's my other factor? X plus 8. In this situation, they both happen to be the same. It could just be x plus 8 squared if you wanted to write it in that more simplified form. I'm cool with this as my answer with two factors that happen to be the same thing. Or you could simply, if you recognize that it's multiplying by itself, you could write this. Either way, we're good. Lily, quick check. What type of trinomial was this? Good. It was a perfect square. Now, I'm going to zoom out just a little bit to see if we can't find a big picture. Lily made reference to a shortcut of some sort, and Ray might be using the same shortcut. Let me do this one quick. Okay, on each of these three problems, and if you have to look at your notes, I'm fine with that. But each of these three, what was the number in front of the x squared? It was a 1 there. What was it here? And here it was also a 1, right? Now, you might have noticed this, or you might not have. But I want to see something. I'm going to look at the magic numbers that we found on each of these, and I'm going to look at the way that it factored in the end. Turns out that maybe, just maybe, there is a situation where we can save some time. Okay, so if I zoom in, and I'm going to use an obnoxious color that I don't use for stuff. Here's my magic numbers. 1, positive 1, and positive 5, right? Notice what showed up in my factorization. Do I have a positive 1 and a positive 5? Well, that's cool, but purely a coincidence, it must be. My magic numbers here were 8 and 8. If I look down at this, did I have two factors that had a positive 8 and a positive 8? Well, gosh, now it's feeling a whole lot less like a coincidence. On the other one, does the same thing happen? Negative 1 and negative 11? Did we have a negative 1 and a negative 11? Holy cow. There's a shortcut at work here. Can we see how it works? Let's see, because I'm getting some nods of people saying yes. If the shortcut does work for you, Carson, this is going to take like 30 seconds. I want x squared plus 12x. Ooh, let's think this one out. Plus 10? Nope, can't do that. It's going to have to be, plus 10 won't work. Sorry. We'll do an easy one. Let's do minus 13. I'm sorry. I'm all over the place because I don't have my fancy calculator to make these problems. Okay. As we look at this, if we compare it to the others, is the leading coefficient the number in front of x squared? Is it a 1 again? So let's start the problem the same way, and we're going to try to use this shortcut. If I take this times this, what do I get? Now, when I say this, I'm talking about the 1 that's really hidden there. What? Negative 13. Can we find two numbers that multiply to be negative 13, but they add up to a positive 12? I think so. 13 is a prime number, so it has to be 1 and 13. Which one of these needs to be negative? Which one has to be positive? Negative 1. How did you come to that determination? Good. Yep, we need the smaller number to be negative so that it's positive when we add them up. Okay, pause here. We don't want to rewrite this thing as a forenomial. Before we continue on, anybody get to this part and you're not quite sure what I've done? Any questions that you have for me? So let's use the shortcut that we saw just a second ago. And whether or not you fully connected it or not, I know that whatever I write here, it has to be 1x squared in the end, right? So I think that x times x will do that. That's why we have our x's here. So I'm going to start. The order is irrelevant. I don't care whether you write negative 1 times 13 or if you write 13 times negative 1. It doesn't matter. I know that if this is indeed a shortcut that's going to work, I have an x. What's one of these numbers? X minus 1. And an x. And what's the other magic number we found? Positive or negative 13? Positive 13. And look at that. We did. We just factored this using a really convenient shortcut. Now, if you're looking at this and thinking, oh, I don't know, I'll verify real quick. You do not have to verify. The shortcut is so convenient. If I wanted to do the whole grouping thing, I could. X squared minus x plus 13x minus 13. Put my parentheses in. X comes out, leaves behind x minus 1. What comes out of this one? 13 leaves behind an x minus 1. X minus 1 and x plus 13. Hey, we get the exact same thing. If the leading coefficient 1 is a shortcut, if the leading coefficient is 1, then there is a shortcut. Carson, if you want to go real quick, you can. All right, go ahead.
Can you put that into like a short little note, like how you did on the other one on the side? Like explaining how.
Like how I did the shortcut?
Yeah.
Yep. If the number in front of x squared, which this is called the leading coefficient, if the number in front of x squared is 1, Then, and I'm going to make you help me to see how we can word this so that it sticks in your head. Are you okay with the number in front of x squared was a 1? Okay. How would you explain these numbers? If I say the magic numbers show up, okay, then I'm just going to say the factorization, the factors are x, and then it's going to be minus or plus depending on the magic number. And I'll just say x. I don't want to write plus or minus because I don't want to confuse you. Magic number 1. And we have to, like in this case, it was minus 1, right? So that's x minus 1 here. And then the other one is x, and then what's the other number that I put here?
13.
And that would be, in this language, magic number 2. Yep, every time this will work. Really important. What was the leading coefficient here? It has to be 1 to be able to use this. So I'm going to keep that up here. We're going to do one more like this, and then we'll jump to magic numbers that maybe don't have a 1. So last one here, x squared plus 6x minus 27. Cool. Factor this one. I would encourage you to try to use the shortcut if you can. I think it works. I'm pretty sure it works. And as I'm walking around, I try pretty hard to not just like look over your shoulder because that always stressed me out. But I do glance at your work, but I'm really walking around just so you can ask questions if you have them. So finding these numbers, and this is a bigger number this time, I would probably do it like this. So if we're looking, let's go back to this one. We're going to multiply, and I'll draw the line here and here. And that's a 1 times a negative 27, which is negative 27. So now let's just start listing these out. If it's a negative number, one of them has to be positive and one of them has to be negative. So I would always start 1 and 27 and just write those first. Now, if they have to, one of them has to be negative, but they have to add up to a positive. Which one of these should be the negative then?
1.
Good, because that'd be negative 1 plus 27 is a positive number. Good, so make that negative. Unfortunately, do these add up to 6?
No.
Okay, so let's try again. Does 2 go into 27?
Yeah.
Does it?
Or no.
Mm-mm. How about 3?
Yeah.
Good. So negative 3 times what?
Times 7.
So that'd be 21.
Oh, so
It's 9. And
Right.
if you use a calculator for this, I have no issue.
Okay.
But what do these add up to?
16.
So are you counting up from negative 3?
Yeah.
So you can do it the other way. Just do 9 minus 3.
6.
Is that that?
Yeah.
So this works perfectly. Our two factors both start with an x, and then you're just going to use your magic numbers. Okay, I'm going to show my work here. And I'm just going to do a little bit more. You might not have had to show both of them. Some of you, I imagine, probably found 9 and negative 3 right off the bat. I'm cool with that. The second that I find these, is this the numbers that you came up with? Do I have to do all the grouping stuff? No, because my leading coefficient is a what? It's a 1. There's a 1 here. We never write it, but it's here. It's hanging out, living its best life. One of the factors, easy, x and what? Minus 3. The other factor is x, and what was my other magic number? It's a 9, but a positive or a plus 9. Boom, we're done. The shortcut is super duper duper beneficial. You should use the shortcut. The one thing I want to caution you that I watch people make mistakes about after we see this, the shortcut only works if and only if the leading coefficient is what number? 1. Okay. Does this all feel familiar? Like it's kind of coming back a bit.
So you're saying the only way this like trick would work is how it's first negative 1 and 27, and if it's a 1 from the start, that's the only way.
This number right here is the one that has to be a 1. The number in front of x squared. Okay, let's bump it up just a little bit then. And let me grab a different sheet because I don't want to make our numbers way uglier than they need to be. I'm going to have you guys do another grouping here. It's not going to be a leading coefficient of 1, just so you're aware. Now, whether we do a ton of stuff with this factoring right now or not, we are going to start the new chapter tomorrow. But since we have a little bit of factoring tools, it is easy for me when you're solving for x or whatever the case is. If I have a way that I can just make it something that requires a little bit of factoring, wouldn't be bad. So we're going to do one more or a few more together. But these ones, I'm going to just call this a new name. That last group of problems that we did, we worked out a shortcut. If and only if what is true about it. Good, and I'm going to keep stressing that. But on this one, example, and I'm grouping still, but we're going to see something a little bit different. And let's check it out. So I got to get to my home screen. And I'm going to use my fancy calculator here to expand some stuff. Cool. Syntax, it doesn't like it. Deal. Okay, I want us to factor this one together. 6x squared plus 9x minus 6. Right off the bat. First question, important question. Can I use the shortcut? Why not? It is not a leading coefficient of 1. Now, in this situation, that's okay. What did we check for first? Before we did any grouping, there was another type of example that we did. Like, you have to look at your notes. It's not on the board. Before we did grouping, 3 letters that we used to represent this. GCF. What does GCF stand for? Before you do anything with a quadratic, which that's what this is, it just means something with x squared, we should check for a GCF. And immediately, as I look at this one, is there a number that clearly and perfectly goes into all 3 of these? A 3. Everybody agree with that? So I'm going to factor a 3 out of all of them, and let's just see what's left behind. If we factored a 3 out or divided this by 3, they're the same thing, what would be inside here? 2x squared, I agree. This one, 3x, I agree with you. And this one? Minus 2. Now, I would always encourage doing the GCF first. You should do it. The good news is that if you don't do it, you still have the possibility of getting the problem right, but your number is going to be much larger. Once we're here, I'm not going to let this 3 disappear. This is just a prime factor. It's a constant that's going to follow us through, but we don't have to do anything else with it in this problem other than write it on each step. We are going to really, truly focus on this one. Now, is there a shortcut here on this inside piece? Okay, so check it out. It feels like a harder question based on the lack of answers. I'm going to pretend that 3 is not there. Is there a shortcut on this trinomial? No, because what's its leading coefficient? It's a 2. It's not a 1 right now. Now that 3 already dealt with, we're not going to forget it, but there's no shortcut here. The good news is that that grouping, it works even if there's not a shortcut. The shortcut's nice if we have a leading coefficient of 1, but we don't. I'm going to multiply these, and I get what number? 4? Negative 4. I now need a combination of one positive and one negative number that adds up to 3. Now, if you struggle, 1 and 4 is where I would start. Which one needs to be negative? If I do the 4, it would be negative 3. It better be that one. Okay, now I don't have a shortcut. I'm going to use these numbers to replace this 3 nomial with a what? A 4 nomial. Do I just leave my 3 behind? No, they're along for the ride. So here we go, a 3. And I'm going to use brackets just so it looks a little bit nicer. What am I going to use these magic numbers to replace? Which specific term? The 3x. That's what we're replacing. So I'm going to write it. I'm going to do the same thing with my color coding. Minus 2. And I'm just going to use this red. Minus x plus 4x. Now, the brackets do make it look, I think, nice. You probably think ugly. I'm only using brackets. You could use parentheses. I'm doing this so it's a little bit easier to differentiate between the two. Okay, we have the identical expression here. The 3 just happened to come out. Whatever, it's cool. I'm going to put some grouping on this, and I want you guys to finish this problem for me. Finish from here, group it, find me my factors. I'll give you all a minute. And I don't really have a hard factoring problem. You want a harder one? Good. Here you go, Lily. Ooh, I'm going to throw you a curveball, okay? No. Sorry. Okay, this one is Lily's, not everybody's. You can do it as well if you want, Ray. What'd you come up with here, Carson? No, you're supposed to be doing it. Put your groups on, your parentheses. Where would you add them? I'm going to smush this candy bar if you don't answer.
What?
Where would you add your parentheses?
On these?
Yeah, where? Good. Just those? All right, I won't smush your candy bar. Now, keep kicking. We'll go to the next line, 3, and what comes out? I'm okay with this. You've switched to these, and you're fine. I would add another big set of parentheses because this 3 would go into everything. I only used, can I write on your?
Yeah.
I only used the brackets, so it looks a little bit nicer. But we really have a big parenthesis there and a big parenthesis there. Because that 3 was connected to everything inside, and now it is.
Yeah.
So in this one, like you're good. That's just a little stylistic thing.
Mm-hmm.
What comes out of this group?
What do you go X on both of them?
I would take out the GCF here. What did you take out of that first one?
X.
And it left behind a 2x minus 1. Okay. I have one little issue with this one. I like that you took out the x, and you can take out a 2 out of this one, right? But can you take out a 2 out of this?
No.
So not quite. So I wouldn't take the 2 out. I would just take an x. And then there's another little hiccup that happened. Yep. We take out an x. It leaves behind 2x minus 1. Hey, now they match.
Mm-hmm.
And that's what I need. One of my factors is 2x minus 1. And you, so,
That's it.
okay, I would just erase this line.
Yeah.
Yeah. Yep. Okay, looking at this, I have done the first group. If we have, hopefully we have the same thing. Vincent, did you get to this point? Okay. Would you like to ask a question? Okay, so we'll check here in a second. What could I possibly take out of this group? If I take out a 2, what does it leave behind? At this point, I know whether or not I'm correct, and I'm convinced that we are correct. How do I know for certain that we are correct? These match. Now, as I go to my next line, the 3 is going to come along for the ride. What is one of the 2 factors we just found? 2x minus 1. Now, the other one is always kind of hidden in here. What's the other one? X plus 2. And we have it. We are factoring at this point. Okay. Last year, you guys loved or hated factoring? It was okay? Raylene, did you like it or hate it? In the middle. Camille? Liked it? Carson? Does it feel any different now than it did last year?
I understand it more.
Don't know why. I guarantee that Russell does the exact same thing. Like, I've done this with Russell. We might draw stuff a little bit differently. I want you guys to do one more for me. And then, is this in your notes? Has this been going in your notes? Okay, keep it in your notes. Don't get rid of it because we'll probably come back to this again. But there's one more that I want you to try. And this one is B. And this is our last problem today. I want you to do x squared. And this is going to seem wonky. And I'm going to write it this first time. Minus 9. And there's something that I want us to make sure we recognize. Maybe there's another shortcut living here or a different type of shortcut. But does this look different than the one that we did before? If you look at every other example that we started with, how many terms were there when we started? 3. Does this one have 3 terms? No, but could it? And it'd be weird to do it, but if you don't remember the shortcut, and you might remember the shortcut, which term am I missing? I have an x squared. What don't I have? I don't have an x. Now, if I wanted to write it, but there's not any of them, what could I possibly write? How many x's? Just x. Do we agree that this says the same thing? Yeah. Now, is the leading coefficient 1? Is there a shortcut then? This one problem is your homework. If you already have it, you might. How did you factor it?
I don't know. I just said what the answer was.
Sure.
I did x minus 9 and then double x plus 1.
So I don't think so, but I'm going to write that here just so we can check, and we'll see why it's not quite right. Try it again with the 0x written in, okay? All right. Peace out, Ray.